So this is Forces in Motion Study Guide, Comp 7. Key vocabulary. So force, a push or pull that can change an object's motion, and for the sketch I put someone pushing a shopping cart. For motion I put change in position of something over time, and I put a car moving. For speed I put how fast something moves over a distance, and I put a speedometer measuring this car's speed. For acceleration, I wrote a change in speed or direction in motion. So that would be a car stopping at a red light, for the example. For gravity, I put force that pulls objects towards Earth. I put a person falling out of bed. For magnetism, I wrote a force that causes metal to repel or attract the opposite force. I wrote fridge magnets. The definition for work: when a force moves an object in the direction of the force. So if he's pushing this box, it goes in that direction that he's pushing. For energy, I put the ability to do work or cause change. So to be able to push that box in that direction that you're pushing. And I put energy powering a light bulb. A simple machine, a device that makes work easier by changing size or direction of a force. So using this lever to move a big rock instead of moving it by yourself. An unbalanced force is a force that causes an object to change its motion because the forces are not equal. So I put a ball after being kicked. Explain Newton's 3 laws of motion in your own words. So for the first law, I put an object will stay still or keep moving the same way unless a force makes it change. For the real life example, I put when a car stops quickly, your body keeps moving forward until the seatbelt stops you. And a classroom safe demonstration is place a book on a desk and show that it does not move until someone pushes it. For the second law, I wrote the more force you use, the more an object will speed up. Heavier objects need more force to move. It is easier to push an empty shopping cart than a full one. And a classroom safe demonstration would be students push a little book and a larger book and compare how fast they move. For the third law, when you push on something, it pushes back with the same force in the opposite direction. Real life example, when you jump, you push down on the ground and the ground pushes you back up. Classroom safe demonstration, students on rolling chairs push off each other and both move. But obviously tell them to do that gently so nobody gets hurt. Which law do students struggle with most and why? I would say Newton's third law confuses students the most because you think only one object is affected, but both objects experience forces. And then these are my speed versus time graphs. So for the car speeding up, the speed goes up, the numbers on the side, as time progresses. A car slowing down, so the car is already at this speed like this, up here, and it slows down. As time progresses, the speed goes down. A car not moving, so the speed is at 0, the time progresses. A car moving at constant speed, so if this 4 means 40 miles per hour, it's moving just at 40 as time progresses. What does a flat line mean on a speed time graph? It means either the speed isn't changing. It's either not moving or it's at a constant speed. It's like these flat ones right here. It's not moving or it's at a constant speed. And a steep slope tells you that the object is changing speed quickly, so acceleration or deceleration. So acceleration, deceleration. Force versus work. Force is a push or pull on an object. Work happens only when that force causes the object to move in the same direction of the force, like when you push the box. When work is not being done, it's like when you push on something that stays in place like a wall. So work is not being done because the object is not moving. Gravitational force pulls all objects with mass towards each other. Magnetic causes magnets and certain metals to attract or repel. Electrical is attraction or repulsion between charged objects. Magnets are usually made from iron, nickel, and cobalt because these metals have magnetic domains that can line up, allowing them to become magnetized. And which has more gravitational force, Earth or Jupiter? Jupiter has more gravitational force because it has much more mass than Earth. Can energy be created or destroyed? No, it cannot be created or destroyed. It can only be transferred and changed from one form to another, such as kinetic, thermal, chemical, potential, light, and electrical. An example of an energy transformation would be a bulb changes electrical energy into light energy. So whenever you flick a light switch and the electrical energy goes into the light fixture and there's light. Simple machines make work easier by changing the amount of force needed or the direction of the force. So an example of a lever would be a seesaw. There's an illustration. An example of a pulley would be a flagpole, like these little ropes right here that allow the flag to go up and down. An inclined plane, I drew a ramp with a skateboard. For a wheel and axle, I drew a door with a doorknob. For a screw, I drew a jar with a jar lid, because there's those little ridges where you can screw the jar lid on and off. And for a wedge, I drew a knife. Thank you.